Hello students, how are you doing all? I am doing great. Hope you are also doing great. Right students, today I would like to discuss one more important concept, that is Bernoulli's equation. So before going to discuss Bernoulli's equation, if you like my videos, please like, share, subscribe my channel, and don't forget to click on the bell icon so that you will receive my new video notifications. Right students, let us dive into our topic, Bernoulli's equation. Right students, what is Bernoulli's equation? So Bernoulli equation can be converted to the linear differential equation. So it is one of the application of linear differential equation. Okay students? Right students? So Bernoulli's equation, actually the general form of Bernoulli equation is this: dy by dx, general form of Bernoulli equation, dy by dx plus px into y equal to qx into y to the power of n. Actually, what is our linear differential equation? Already you know. Yes, exactly students. dy by dx plus py equal to q. This is our linear differential equation. So what is the difference between linear and Bernoulli? Yes, exactly. There is a y to the power of n in the RHS part multiplied with qx. This is only the difference. So if we remove this y to the power of n, removing means not crossing. Okay, so we have to remove that y to the power of n by proper substitution. It is very important. Okay, we have to remove the y to the power of n in the RHS side, and we have to convert the equation into the form of linear differential equation. Okay, so first what is the method of removing the y to the power of n from the RHS side is, so first step is we have to divide the total equation by y to the power of n, so that we get here 1 by y to the power of n. 1 by y to the power of n is nothing but y to the power of minus n. Y to the power of minus n. Okay students, y to the power of minus n into dy by dx plus px into y by y to the power of n. Y by y to the power of n. Y by y to the power of n, this y to the power of n, denominator y to the power of n goes to the numerator, then what happens students? Y to the power of 1 minus n. That's what we write here. Y to the power of 1 minus n. That is equal to q of x. This is the step number 1. Now step number 2. Let y to the power of 1 minus n, okay, because we have dy by dx plus, we have to change it the form dy by dx plus py. So here must be only y, here it is y, then it should be y here, like that. Here it is v, it should be v here. Here it is t, it should be t here. Here it is p, it should be p here, like that. We have to change it like that. Okay, so that we are writing in the place of y to the power of 1 minus n v, so that it converted to p into v, so that it should be converted, dy by dx also should converted to dv by dx. If dy by dx converted to dv by dx and it is v, then it converted to the linear differential equation. Okay students, so we are trying to convert it into the form of linear differential equation by substituting y to the power of 1 minus n is equal to v. Okay students, so how to convert a linear differential equation we'll see in one example students. Okay, sometimes the general form of Bernoulli equation is also like this: f dash y into dy by dx plus px into f of y equal to qx. That means here f of y and this differentiation, the differentiation of f of y is the multiple of dy by dx, that is f dash y, then also we can convert the equation into the form of linear differential equation by substituting f of y equal to v. So these two are Bernoullis equation. One is Bernoullis equation and general form of Bernoulli equation. Okay, students. So now we are moving to do some problems on this. Right, students. So see here. Yeah. Solve x into dy by dx plus y equal to x square into y to the power of 6. Okay, students. So if you observe the LHS part, it is of the form clearly linear differential equation, x into dy by dx plus y. If you observe the RHS part, x square into y to the power of 6. So if this y to the power of 6 is not there, then it is clearly linear differential equation. How do we solve it? Okay, what is the process? Just simply dividing by x. Simply dividing by x. Dy by dx plus y by x is equal to x square by x. Then it converted to the linear differential equation, general form. It converted to general form of linear differential equation. But here, what we are having? Y to the power of 6. There is a term y to the power of 6 is there in the RHS side. So that it is Bernoullis equation. So it is q into y to the power of n. It is of the form dy by dx plus py is equal to q into y to the power of n. It is of the form. So that first we have to convert it into the form of linear differential equation. For that one, first step is we have to divide by x. We have to divide by the differential coefficient x. Then after, the next step will come to the place. Okay, students. So here we are doing this one first. We are dividing by x. So if we divide by x, what happens? Dy by dx plus 1 by x into y, 1 by x into y equal to x square by x is nothing but x into y to the power of 6. So which is Bernoulli's equation. Clearly this is the general form of Bernoulli equation. First form of Bernoulli equation. We consider it as first form of Bernoulli equation. Okay, students. Now to convert this equation into the linear form, what we have to do? We have to do by divide by y to the power of x. So it converted to y to the power of minus x into dy by dx plus 1 by x into y to the power of minus 5 is equal to x. Now what is the next step? Taking y to the power of minus 5. Okay, students, y to the power of minus 5 equal to v. So this p into y linear form. So we have to convert it into the form of p into t or p into v, any substitution as you like. You can take it as v or you can take it as t. Some may take it as t, some may take it as v. Okay, according to our convenience. So I am taking here as v. So y to the power of minus 5 equal to v. Now doing the differentiation on both sides. So the differentiation of y to the power of y to the power of minus 5 d by dx of with respect to x, d by dx of y to the power of minus 5 is equal to dv by dx. Now here what is in the place of n? Minus 5. So here d by dx of x to the power of n formula is n into x to the power of n minus 1, n into x to the power of n minus 1. So that what is in the place of n? Minus 5. Minus 5 into y to the power of minus 5 minus 1, that is y to the power of minus 6 into dy by dx, that is equal to dv by dx. Okay, students. Now we have to substitute this in the equation. Okay, so eliminate y by substituting 2 and 3 in 1. What is mean by 2 and 3? This is equation 1 and this is equation 2 and this is equation 3. So y to the power of minus 5 in equal to v, so it can write it as minus dy by dx is equal to 1 by minus 5 into y to the power of minus 6 into dv by dx. We are substituting these values in this equation. Okay, let us see what happens here. Y to the power of minus 6 into y to the power of minus 6 into dy by dx is there here, and 1 by x into y to the power of minus 5 is there. So we are substituting the values. Y to the power of minus 6 into dy by dx. Y to the power of minus 6 into dy by dx is equal to what? Y to the power of minus 6 into dy by dx is equal to what? Y to the power of minus 6 into dy by dx is equal to minus 1 by 5, cross multiplication, 1 minus 1 by 5 into dv by dx. Okay students, so y to the power of minus 6 into dy by dx is equal to minus 1 by 5 into dv by dx plus 1 by x into y to the power of minus 5 is v, that is equal to x. Now it converted to the linear differential equation. Clearly it converted to the linear differential equation. If we cross multiply this minus 5 to the taking LCM of minus 5, then it converted to dv by dx. Okay, dv by dx minus 5 by x minus 5 by x equal to minus 5x. Okay students, let us see. Okay, dv by dx plus minus 5 by x into v equal to minus 5x. So it is clearly of the form linear differential equation. dv by dx v. Okay, it is a linear differential equation in terms of v. So here if doesn't change because here also p and q are functions in terms of x. P and q are functions in terms of x, so if doesn't change. So the solution changes. What is the solution? It is a linear differential equation in terms of v. So our solution is v into if equal to integral q into if into dx plus c. Okay, v into if in the place of y, here we get v into if is equal integral q into if into dx. Okay students, now we first find the if. So what is the if here? What is the if? So to find if, we have to find the p and q values. Comparing the values, we get p equal to minus 5x and q equal to, p equal to minus 5 by x and q equal to minus 5x. Now first we are finding integral p dx. Same as it is process. When we converted to the linear differential equation, the same process of linear differential equation is applicable here also. Okay, please remember that. So very simple as linear differential equation. Okay, integral p dx is equal minus 5 by x into dx, that is minus 5 log x, that is equal to log of this 5 minus 5 can be taken to the internal of logarithm log x to the power of minus 5, m log n formula, log x to the power of minus 5. Okay students, now e to the power of integral p dx, this is the if formula, e to the power of integral p dx, that is e to the power of log x to the power of minus 5. Already we know e power and log, e and log get cancelled. If e to the power of log is there, e and log get cancelled and the functional value will come to the RHS, that is x to the power of minus 5. Okay students, right, is it clear up to now? Very good. Now our solution is v into if, okay, v into, wait a moment, okay, v into if is equal integral q into if into dx, okay. So v means already our substitution, v equal to what we substituted in the place of v. So you have to remember that v in the place of v, what we substituted, okay, v is y to the power of minus 5, y to the power of minus 5, we have to substitute that again in the last step. Okay, so v means y to the power of minus 5, y to the power of minus 5 into if is nothing but x to the power of minus 5, if is x to the power of minus 5, so we are substituting the values, v into x to the power of minus 5, that is y to the power of minus 5 into x to the power of minus 5 is equal to q is minus 5x, so minus 5x into if is x to the power of minus 5 into dx. Now y to the power of minus 5 into x to the power of minus 5 is equal to minus 5 into x to the power of minus 5. X into x to the power of minus 5 is nothing but x to the power of minus 4 into dx. X to the power of minus 4. So x to the power of minus 4 integration is x to the power of minus 4 plus 1 by minus 4 plus 1 plus c. Okay, that's what I have written here. X to the power of minus 4 plus 1 by minus 4 plus 1 plus c. Okay, students. So then final solution is y to the power of minus 5 into x to the power of minus 5. We can write it as 1 by y to the power of x 5 into x to the power of 5. We can take it in the denominator, negative will be positive. 1 by y to the power of 5 into x to the power of 5 equal to, so here x to the power of minus 4 plus 1 is x to the power of minus 3, x to the power of minus 3, okay, x to the power of minus 3 by minus 3. So minus minus plus and 5 by 3 into x cube. X to the power of minus 3 can be taken to the denominator, x cube plus c. Okay, students, this is how we do the Bernoulli differential equation. So step number 1, once again I am repeating you, step number 1, first you have to divide by the RHS y to the power of n. The general form of Bernoulli equation is dy by dx plus py equal to q into y to the power of n. So we have to divide by y to the power of n. Then after we have to substitute p coefficient. What is the p coefficient? Y to the power of 1 minus n. Y to the power of 1 minus n is equal to y to the power of 1 minus n is equal to v. Then differentiating both sides of the equation and we substitute in the given equation, we converted into the form of linear differential equation, then solve by using the linear differential equation method. So this is about how to solve Bernoulli's equation. In next class we see some more examples of Bernoulli differential equation, right students? So before going to close this session, I am requesting you, please, if you like my videos, share, subscribe, like, and don't forget to click on the bell icon so that you will receive my new video notifications. And I want to share one more thing. You share my videos to the needy students who are studying BTech or intermediate or diploma or pharmacy students. Right, students, thank you all. Signing off, Sridhar.